First, the eye. Charles Darwin himself said, "To this day, the eye makes me shudder." Creationists are particularly fond of the eye because they like saying, what is the use of half an eye? An eye only works, they say, if every little detail is in place. Until you've got that, the eye won't see anything at all, so how could it possibly have evolved? And even serious scientists have sometimes queried whether there's been enough time for the evolution of the eye. Well, suppose we start with an ancestor who didn't really have an eye at all, but just a single, simple sheet of light-sensitive cells. That's represented by this screen here, and there's a television camera behind looking at the screen so that we on the screen, on the television screen, shall see what this primitive animal would see. So this animal, with hardly any eye at all, will at least be able to tell the difference between light and dark. Light and dark. Now, the next stage in evolution would be to have a shallow cup. This animal would be able to tell the direction that light is coming from, because a shadow would appear. A shadow would appear there. And if you can tell the direction a light is coming from, then you can tell the direction that a predator is coming from. Now, although we've represented this as a cup coming out from the wall, it would in fact probably be an indentation, and it would be a gradual indentation. It's inconvenient to make a gradual indentation. It has to be made as a rather abrupt cup that comes out 6 inches at a time. But it's easy to see that that shadow effect that we've just been witnessing would work progressively and gradually as the cup gets bigger. Let's make it bigger still now, Bryson. And this cup is even more effective. And if we go on to the next stage where we make the cup gradually bigger again, so big that it becomes just a little hole in the end. Right, now this animal has a very good idea of exactly where the light is, and by the same token exactly where, for example, a predator is. And I think with this eye we might even get a little image. See if we can get an image of Bryson's hand. That smudge there is Bryson's hand, and you can just about see a very dim image of his fingers. So an animal with an eye like this would be able to see perhaps just a little bit what kind of predator it was. Let's go to the logical conclusion, which would be a pinhole. Remember, this is all gradual change in evolution. Right, let's see if we can see your hand again, Bryson. Now I can see a rather precise picture of Bryson's hand. It's not a very bright one, but I can see every finger clearly delimited. So I could see, if I were this animal, I could see my predator in some detail. There is an animal that has a pinhole camera for an eye. It's a mollusk called nautilus. It's a relative of the octopus, but it lives in a shell, and there is its eye. It just has a simple hole, and seawater can flow in and out of that hole. Here's the shell of nautilus. This bit of rock here shows ammonites, which are a now extinct relative of nautilus. They were once immensely common, as this rock suggests. I like to think of all those 100-million-year-old dramas that must have been witnessed through the pinhole camera eyes of ammonites. We can't be sure they had pinhole camera eyes, but it seems quite likely. Now, a pinhole camera is not a very good way of seeing. It does produce a sharp image, but because it's so narrow, you hardly get any light in. The answer to this problem is that ingenious device, the lens. Nautilus has a pretty poor eye compared with its relatives, the squids and octopuses, because they do have a lens. And so we can't help wondering, why doesn't Nautilus have a lens? Why didn't it evolve a lens? Well, I suspect that Nautilus may have got itself stuck on a little peak some way up Mount Improbable. you see that although we've got one big peak there, there are various other peaks on the way. There are quite a lot of them. And since the rule in evolution is just to keep going uphill, when the ancestors of Nautilus came up the track here, up the path here, and got to this point, that way uphill looked just as inviting, so to speak, evolutionarily, as that way. Both of them were uphill. Evolution has no foresight. Evolution has no way of knowing that if you travel up that way, you're going to end up with a lens. For the moment, this appears to be a perfectly good way to travel because the pinhole camera at this level of illumination is an effective eye. So I wonder whether perhaps Nautilus has got itself trapped on top of this little hillock and is now unable to escape, because escaping would mean going downhill into the valley, and the one thing you cannot do on Mount Improbable is ever go downhill. But let's imagine what the ancestors of the squid and octopus did when they got to this junction point here. They just happened to go on up this way, and they started evolving a lens, and we did at a different time in history. How might the lens have evolved? Well, let's imagine that it started with just a single transparent sheet of some transparent material. And all that this was doing, it's not a lens yet, all that it's doing is protecting the eye. In Nautilus, seawater flows right inside the eye. This animal now has some protection. And the eye is really just the same as though there wasn't any transparent material there. Now, we're going to use an optician's set of lenses here. It would be nice to be able to have just one bit of transparent material which we would then squeeze and make thicker. But we can't do that, so we're going to replicate that effect by a whole series of little lenses. So this is the next stage in evolution. This animal here, let's get an image of that. Okay, that's a rather better and above all brighter image of the hand. Let's have the next lens in. Right, now, if an animal that had an eye like that would have a really very, very clear view of its world, it could tell exactly what its predator was. Would anybody like to come out and have their face looked at? Right, yes. What's your name?
Davina.
Say it again?
Davina.
Davina. Now, did you remember where Bryson put his hand? Can you put your face just down there? We need the lights down, I think, for this, don't we? There we are. Very nice. This animal can even see what its predator's face looks like. Upside down, but we all see upside down. Thank you very much, Davina. So we have a gradual pathway all the way up Mount Improbable from no eye to an eye. But has there been enough time for the evolution of the eye? Well, recently a Swedish scientist called Dan Nilsson has tried to answer that question. He did pretty much the same as we've just been doing here, but he did it with a computer. So instead of growing up in big steps, as we had to do with our wooden model, he was able to do it in very small steps on his computer. In fact, very small steps indeed, deliberately. He assumed that each step, which means each mutation, caused only a 1% change in the size of something, like, say, the steepness of a cup. He also devised a way of measuring the efficiency of an eye. He did this by telling the computer to measure various things about the eye that it had just drawn itself. And then the computer worked out, using the rules of physics, how good an image that eye would be capable of producing. And the question was, with those rules built into it, would there be a smooth gradient of improvement, starting out with a flat retina and ending with a proper eye like ours? And you've guessed it, the answer is yes. This was Nielsen's starting point, with just a flat retina under a flat transparent layer. And now let's just run the simulation of, these are the successive stages that Nielsen got, and they're pretty similar to the successive stages that Bryson got with his model. So far we haven't learned anything that we didn't already know. There is a smooth progression up Mount Improbable for the eye. But Nielsen went on to estimate how many generations it would take to accomplish this evolution. In order to do this, he had to make some more detailed assumptions. I won't bother you with exactly what they were. All you need know is that they were quantities which geneticists out in the field can measure and have measured. And Nielsen put into his computer model values of these quantities that were conservative. Conservative means that he was erring on the side of deliberately biasing his calculation to make it slow, to give it an estimate on the slow side of evolution, make evolution come out slower than it might otherwise have done. But in spite of this, in spite of his being conservative, and in spite of assuming that each mutation could only cause a 1% change, which is another conservative assumption, Nielsen found that the evolution of the eye, we've just seen, would take a surprisingly short time. It would take about 250,000 generations. Well, that might sound like quite a lot of generations, but we have a rather warped perspective, because after all, each one of us is only good for one generation. But our human perspective is not the one that matters. The one that matters is the geological timescale. And on the geological timescale, 250,000 generations is next to nothing. Probably only about 250,000 years, since the animals we're talking about would probably have had a generation time of about a year. And 250,000 years is really too short for geologists to even measure. It's like trying to count seconds using the hour hand of your watch. So there really was no need for Darwin to shudder. Half an eye is better than no eye. Half an eye is better than 49% of an eye. 1% of an eye is better than no eye at all. And far from there not being enough time for the evolution of the eye, the evolution of the eye is so quick and easy that it must have happened many, many times over. Eyes can evolve at the drop of a hat. And in fact, if we look around the animal kingdom, there are lots of different kinds of eyes dotted around, and each of them is different. Many of them work on completely different principles, and they have evolved quite independently of each other, many times over. This is the shell of a scallop, a kind of shellfish. These things are not pearls, they're eyes. But they're a very different kind of eye from anything we've seen and anything that we normally think about. Those eyes are reflector eyes. They have mirrors instead of lenses. Each one of these is a little curved mirror which works like the Jodrell Bank telescope and forms an image in the way that a reflecting telescope does, not in the way that our eyes do. This is a compound eye of an insect. Each one of these little facets is one little eye, and the whole assembly together is interpreted by the brain to make one big image. Next eye, next one. These headlights belong to a spider. Once again, this is entirely independent evolution of the eye. It's nothing to do with the other eyes that we've seen. And next, and finally the eye of a squid. This is the skin of a squid. There's its eye. The squid has a very excellent eye, very like ours, with a proper lens, proper camera principle. But you can tell by looking at the details of it, especially how it develops, that it evolved entirely independently of ours. The same principle was hit on entirely independently of ours. Once again, remember that each step is a small piece of random luck. As such, each step is not particularly impressive. In fact, it had better not be impressive, because if it was, it would be a miracle, and we'd no longer have a true explanation. The whole point of evolution is that it gets us up Mount Improbable without miracles.